Today we are talking about vectors. Many objects in physics are vectors. For example, velocity, force, acceleration. And vectors are characterized by non-negative magnitude and direction. For example, when you drive a car, you see a speedometer that shows how fast you're going. It shows your speed. However, your speedometer doesn't show you where you're going. It doesn't show you direction. But velocity combines both the speed and the direction of motion. Another example of a vector is a force. Normally we're interested in both how hard we push, magnitude, measured in newtons, and also we're interested in the direction where we push. Typically a vector is represented by an arrow, and the length of arrow is representative of the magnitude. So for example, in the case of velocity, the magnitude will represent the speed. And if let's assume this vector represents velocity with a speed of 20 meters per second, if I'm interested in the velocity vector with the speed of 10 meters per second, that vector will be half as long. Let's consider a 1D case. It turned out that in this case we can just use one real number to represent a vector. So here we have a brake that's being pulled by two forces. We have 10 Newton force to the right and 30 Newton force to the left. We will introduce a coordinate system that will consist of one axis in this case. And let's assume that the right direction is positive direction where we have the arrowhead. In this case, the left direction will be in negative direction. In this case, we're going to write a vector that represents 10 newtons to the right as plus 10 newtons because it's in the positive direction, and the vector that represents at 30 newtons to the left as minus 30 newtons because it's in the negative direction of the axis. Now if you would like to calculate the net force, which is a sum of all forces, but the sum has to be understood in a vector sense. In this case, we need to add this 10 newtons and minus 30 newtons. As the result, we get minus 20 newtons, which means that the force is 20 newtons in magnitude, and minus means it's to the left, in the negative direction of the axis. Now what should we do in a two-dimensional case? For example, we have this vector in 2D. The magnitude of this vector is 50. To handle this vector, one number is no longer sufficient because number of directions in 2D is infinite. Instead, what we can do, we can use two numbers to describe a vector in two-dimensional space. The way we're going to do it, first, we introduce a coordinate system. First, we choose one axis, and we can choose this axis any way we want. I'm choosing a horizontal axis in this case, and the arrow indicates the positive direction of this axis. And let's call this axis X. The second axis will be at 90 degrees to the first axis. And again, we choose a positive direction. It's up to us to choose whether we want to go up or go down. We choose to go up. And we're going to call this axis Y. And to figure out what this vector is, so how can we describe this vector, what we're going to do, we're going to start at the beginning of this vector, right here, and going to go to the end of this vector, right here. But we're going to go in a special way. First, we're going to move along the horizontal direction, along the X direction, and then we're going to move along the Y direction. In this case, we're going to move first along the green horizontal vector and then vertical red vector. The green vector indicates that we are moving minus 40 points in horizontal direction. Minus 40 means we are moving 40 points, but in a negative direction of horizontal axis X. The vertical vector indicates that we are moving plus 30 points up. Plus 30 points means we're moving 30 points, and plus means we're moving in a positive direction, y. In this case, our vector, which we're going to call vector v, could be represented by two components. We call it component along the x direction and along the y direction. The first component will be minus 40, the second will be 30. The other thing to notice that 30 squared plus 40 squared in our case should be equal to 50 squared. And that's because what we have here is a right triangle, and 30, 40, and 50 represent sides of the right triangle, but sides of the right triangle have to satisfy Pythagorean theorem, which says that this side squared plus this side squared should be equal to this side squared. Now, how can we use this information? The fact that we can split any vector into components, into the along the x coordinate and along the y coordinate. We can do this pretty much with any vector. Whether it's a force, we can take a force vector and split into components. We can take velocity vector and split into components. We can take acceleration vector and split into components. We can do this to any vectors. So now, let's consider Newton's second law that says the net force, or sum of all the forces, equals mass times acceleration. The way we need to understand this is first by splitting both force and acceleration into two components. Force has component along the x direction and y direction. Acceleration has two components along the x direction and y direction. And what we should understand by this equation is that this equation should be applied to both x component and y component independently. So fx should be equals to m times ax, and fy should be equal to may. Now, we could stop here, but there's still a question about how we calculate fnet. Normally we don't know fnet. What we do know is all these separate forces that apply to the object. And fnet is the sum of all these forces. What we mean by sum of the forces means the sum of the forces in the vector sense. So if, for example, fnet consists of two forces A and B, we need to add these two forces together, but we have to do it by applying rules of vector addition. So if our vector A and B have components x and y, when you add two vectors, you simply add the respective components. So x component of the sum of these two vectors is the sum of x components of each of these vectors. Y components of the sum is the sum of y components of each of those vectors. And as we saw, the x component of this vector is really what we call fx here. Y component here is what we call fy. Let's apply this knowledge to a physics problem. So here we have a brick that sits on the surface, and the brick is being dragged with a force of 20 newtons to the right. There is a friction between the brick and the surface, and that friction force resists the motion of the brick. The friction force applies a force of 10 newtons to the left. The brick's mass is 10 kilograms, and we ask to find acceleration of this brick. First of all, we need to draw all the forces. We already have two horizontal forces, the force F and the friction force, but there are two other forces. Those are vertical forces, the force of gravity or weight, and also a normal or support force. Since the object is being dragged along the surface, we assume the object doesn't jump from the surface, stay on the surface. So all the acceleration is along the horizontal direction. The next thing we're going to do, we're going to introduce a coordinate system. We have x-axis, y-axis, a horizontal and vertical axis. Positive direction of x-axis is to the right. Positive direction of y-axis is up. Now, if you want to write Newton's second law, it tells us that sum of all forces on net force equals to mass times acceleration. The next thing we're going to do, we're going to find the components of all the forces and acceleration on x-coordinate and y-coordinate. Let's start with the force F. We see it's a horizontal force with magnitude of 20 newtons. So since it's horizontal, it means that the component of this force will be 20 newtons in x direction and 0 in the y direction. It is plus 10 because it's in the positive direction of the x-axis. Friction force is 10 newtons in the left direction, and that is a negative direction of x-axis. So friction force will be minus 10 newtons horizontally and 0 vertical. When it comes to gravity or weight, it's a vertical force. It has 0 component in the horizontal axis, but it has a value of minus 100 newtons vertically. Why minus 100 newtons? Because it's m times gravitational acceleration. M is 10 kilograms, gravitational acceleration about 10 meters per second squared. Now we're putting minus here because it's in the direction opposite of our axis y. It's in a negative direction. And finally, we have a normal force sitting here. That normal force, which we don't know the value. We know it's vertical, so we know it's 0 horizontally. But vertically we don't know, so we're just going to leave it as Fm. And we're going to find out what it is later. And finally, MA. Horizontally, MA is M10 times A. That's what we write here. And vertically, as we said, the object doesn't move, so it's 0. And now we're going to write Newton's second law on x component and on y component separately. So on x component, it means that sum of x components of all these vectors equal to the x component of MA. And sum of y components of these vectors equals to y component of MA. So for x components, we see that Fn has 0, mg has 0, F friction has minus 10, F has 20, and MA has 10A. For y components, we see that Fn has Fn value, mg has minus 100, and friction and F force have 0, and MA is also 0. From the second equation, we see that magnitude of the normal force is 100 newtons. And from the first equation, we can find acceleration, which is 1 meter per second squared. And that's it. But if you're interested in more complicated problems, I have another video, and there's a link below, where I have an object sliding down the slope. The complication in that case is that some forces are not along the direction of the axis. So they have components both on x and on y direction. If you're interested, you're welcome to watch that video.